Okay, the next question we need to answer is if you're giving an equation. Say this p of x is equal to x to the third plus 3x squared minus x minus 3. And I ask you to find the local maximum or minimums as well as the intervals of increase and decrease for that polynomial. How can you do that? Well, there's some hard ways to do it and there's some easy ways to do it. And I would rather show you the easy way, but that requires a graphing calculator. So what you need to do is you need to get out your graphing calculator, just like I have right here. And that's not where you want to be. And you need to graph that equation. So just to save on time, I've put the equation in here. To graph it though, you go y equals, and you put x to the third plus 3x squared minus x minus 3. And then you click on the graph button, and you get a nice graph like this. Now I had to change the window around, and you might have to do that too. Zoom in and zoom out using these features right here, the zoom in feature or the window feature to change this window. But that's something you can play around with. And so I have my graph here, and I can identify here's a local maximum right there. And what does that local maximum look like? Well, I could zoom in a little bit more. I'm not going to do that right now, but I could guesstimate that it's probably negative 2.25, so negative 2.25. And then how high is it up? Let's see how high it is up. 1, 2, 3, around 3, something like that. You could zoom in to get more accuracy there. And I got a local min down here. And that local min looks like it's at maybe, I don't know, maybe 0.1, comma, and then how low is it? 1, 2, negative 3, something like that. That's my local min. So I've identified the local mins. Now I need to figure out the intervals of increase and decrease. To do that, again, you just draw a vertical line through the local maxes and mins, just like I'm doing right here. Just like I'm doing. Yeah, just like this. Okay? And let's focus on the first one on the left, the furthest one to the left here. Okay, so we want to focus on this interval. What's happening in this interval? Well, it looks like it's increasing during this interval, so it's going up. But now how would we write that? How would we mathematically write that it's increasing up, or that interval? How do we write that interval? Well, this is how you do it. You put x. We know that x is greater than infinity, or actually negative infinity. Because this thing, this polynomial, goes this way forever and ever. I guess talk about end behavior. We'll talk about that a little bit later. So x is greater than negative infinity, from negative infinity, and when does it stop going up? Well, it stops going up at this x value right here, this negative 2.25. So it's increasing from x, from negative infinity to negative 2.25. Okay, so that's an increase. That's one interval increase. I'll put that down on the bottom. Negative infinity is less than x is less than negative 2.25. Okay. Let's try to find another interval. Let's do this middle one right here. Okay. From here to here, looks like what's going on? Well, it's decreasing. So what interval is it decreasing? Well, it's decreasing from, it looks like again, negative 2.25. So when x is greater than negative 2.25, but when x is less than, when does it stop decreasing? Looks like it's about 0.1. Sorry, right here. It's 0.1. So 0.1. And that's an interval of decrease. I'll put that down here. So negative 2.25, x is greater than that, and when it's less than 0.1, that's when it's decreasing. And we have one more interval over here. This right interval over here looks like it's increasing again. When do you think this thing stops increasing? Well, it never does. This thing goes on forever and ever. It's always increasing from here on out. And when does that start? Well, it looks like it starts again at 0.1. So when x is greater than 0.1, and when does it stop increasing? Well, it never stops increasing, so we just designate that as infinity. So we can put that as another one under the increase. From 0.1 is less than x is less than infinity. And that's how you determine the intervals of increase and decrease, as well as the local maximums and minimums using a graphing calculator.